let's start off with what is GIS and what is GI science? Many of you may have heard of GIS, which is probably why you're here taking this class. But many of you may not have heard of GI science. So let's break these terms down. GIS means Geographic Information Systems. Geographic relates to the specific place on Earth or in relationship to somewhere on the Earth's surface. Information is data which has some value or interpretation that's been added. So it's not just data, there's some sort of interpretation that goes along with it. In geographic information, the information relates to things like measurements, maps, images, sounds, all of the Earth's surface. And then finally, systems really refers to a system that's designed to perform a wide range of functions on or with the geographic information. GI science, on the other hand, is where the word systems is replaced with science. Michael Goodchild, a now retired professor, whose research advanced the science of GIS, describes GI science as the science of the systems. We can divide this out a little bit more. The science is the research and ontologies that go into creating the system. In this class, I often describe GI science as what we do in lecture, and the systems is what you do in lab. These are fundamentally linked. We wouldn't have a computer system like ArcGIS if we didn't have the research that went into thinking about how to make the world fit into a computer information system. I also think the science is vital to being able to really know what you're doing with GIS and not just clicking on buttons. The systems, on the other hand, are the system that you use to do your analysis. In this class, we use ArcGIS, but there are many other software applications out there that can do analysis like ArcGIS. QGIS is one example. Nowadays, there's also web GISs that work within your browser, but ArcGIS is the industry standard, and it's the most robust of all of the systems out there, which is why we teach it in this class. After this class, though, I recommend you go out and learn some other technology on your own. We provide you step-by-step instructions and video tutorials now, but that won't be the case for everything that you do. Most of these GISs come with a GUI, or a graphical user interface, aka you aren't writing in command line. An example of when you do use command line would be something like the R program for doing statistics. A GUI means that you have buttons to press and drop-down menus, tabs, and a ribbon, just like you have in many other desktop applications like Word or PowerPoint. So why do these two terms matter? Many of you probably chose to take this class because you wanted to learn how to map something, or your advisor or other mentor told you that it was an important skill to gain. But let's really dig into why these matter. First off, spatial is special. This is often a geographer's favorite phrase, but really, why is spatial information important? You might be able to think of some examples of when spatial information is important, from getting directions to a place you've never been to understanding why there's differences between here and Portland or differences between Portland and New York City. Thinking spatially lets you think about the patterns that vary across space. For instance, things are not the same everywhere. Eugene has a lot of people who root for the Ducks on football Saturdays. Corvallis, on the other hand, has a lot of people who root for the Beavers. Let's dig in a little bit more. Entities and events are likely to occur somewhere. By viewing geographic information visually and combining the layers of information, we can start to see patterns emerge across space. Geographic information systems combine spatial or mapped information with an information system that's the database about these entities. We'll talk a lot more about this throughout the course, so if you don't totally understand what I'm talking about right now, don't worry. When you work with a GIS, you're taking the real world information about it and simplifying it down into something a computer system can organize and map. Finally, it wouldn't be a geography class if we didn't talk about Tobler's first law as why spatial is special. In 1970, Waldo Tobler said that everything is related to everything else, but near things are more related than distant things. This makes sense, a lot of sense. Things that are closer often have things more in common with each other. Now let's talk about Jon Snow. Who was this guy? Jon Snow was a physician. He was considered one of the founders of modern epidemiology. Now, why are we talking about epidemiology in a GIS class? Well, a lot of epidemiology is tied to geography. Epidemiologists look at patterns of disease, and a lot about disease is spatial because it's related to where people are, where things might get them sick, and where people might transfer the disease to each other. In 1854, there was a major cholera outbreak in the Soho neighborhood of London. At that point, it wasn't completely clear what caused cholera, but mapping it made it clear that it was connected to a water source. In this case, Jon Snow mapped the disease cases around these water pumps. It was clear that the pump was the cause. Although Jon Snow's chemical and microscopic examination of a water sample from the Broad Street pump didn't conclusively prove its danger, his studies were convincing enough to persuade the local council to disable the water pump. Now let's recap. You need to know the difference between GIS and GI science. Generally understand why spatial is special and what the first law of geography is. And then finally, know why Jon Snow is important for geography and epidemiology. I'll see you in the next video.